Okay, so the last couple of days we've been talking about using math operators in our programs. There are some problems, and this would be, an example of one of those problems where we can't use just simple math operators to solve it. Okay, we need something like a square root, or maybe there's other problems where we need to find like an arc cosine or a cosine or a tangent or something like that. And those aren't just simple math operators. So we need another way of doing that, and the way that is supplied to us is through what's called the math class. Okay, so there's a class kind of like string, kind of like graphics, that's called math, and it has a bunch of methods that are available to us. And on the website, I've kind of given you an example of the ones that I think will make sense for most of you, and the ones that we might use in whatever kind of programs we might be writing up after this point. So unfortunately, the way that this is formatted, this is the return type in this first column. I'll try to fix that, but they're all doubles pretty much. Some of the ones that return doubles also have a version of that method that will return an int. So for example, ABS is for absolute value. If you send it a double, it'll give you back the absolute value of that double. If you send it an int, it'll give you the absolute value of that int. Okay? When there's things like the sine method, okay? So if you guys have done any trigonometry, like in geometry or algebra 2 or something like that, then you know what the sine of an angle is, okay? I just list sine here. I'm not listing cosine and tangent because I'm assuming that if you know that there's a sine, then you would think there should be a cosine and a tangent. Okay? The weird thing here is when you use the sine method, it assumes that your number that you're sending it, your angle, is in radians. Okay? So if we need to do a little mini lesson on the difference between degrees and radians, then we can do that. But I'm not too worried about that stuff right now. Okay, so so don't fret as far as that goes. Right now we're just trying to figure out how to use these methods inside of a program. Okay, so let's go back here, and we're going to work our way towards being able to solve something like this electron velocity problem. So let's go over to Eclipse. We did using math operators the last couple days. Today we're going to do a new class called Using Math Methods. Okay, so we want that to have a main method, and once you have Using Math Methods and the main method, then you can finish. Okay, so there are a bunch of different examples that we could go through, but let's just kind of start out nice and easy here. So let's go ahead and create a double variable. All right, and I'm just going to call that thing x equal to math.sqrt. So that's finding the square root. And let's just find the square root of 100 because that's something that we feel like we should know. And then let's just print out x so you guys can see what happens here. Okay. Okay, so what it prints out there is x is equal to 10.0. All right. So what happens again, we kind of talked about this the other day. When I send square root an int instead of a double, that int gets automatically promoted to being a double. So it receives it at as 100.0, and then it's finding the square root of that number. And we don't really, the nice thing about this is we don't really need to know how it finds the square root, it just does it for us. Okay, so in general, this is the way that we use all of the math methods. So math dot whatever it is that we want to do, and then we just have to look up which method we want to use. Okay. So let's just kind of continue down the line here. Let's go ahead and say double m equals math.sqrt, and let's go ahead and, I'm sorry, not math.sqrt, but math.max. We already did sqrt. Okay, so max is going to return the bigger value between two different values. Okay, so real simply, if I put in 34 and then I put in 87, okay, and then I print out m, okay, m should be what in this case? What do you guys think? 87, right? All right. So we got 10 that came from the square root, and then we got 87. And again, it's a double value, okay, right here. If I change this value to an int, all right, then I get just the regular value 87, or just the whole number value 87. So the last one we got 87.0, but I was sending it to ints, so it figures out, oh, 87 is the bigger of those two, promote it to a double, okay, and m became 87.0. All right, so you got to be careful with these that you don't mix up the type. All right, so if I say like, so if I go back and I make this double, all right, we know that that's going to be 87.0. So now I could do 34.5 and 87.9, all right, and it's going to give me back 87.9 as the max. Okay, so hopefully that makes sense. If I try to change this to int, now it's going to have an issue with that because I'm giving it two doubles, so it knows that it's going to give me back a double. So this is going to be the double 87.9, and I can't store that in the int called m. Okay?
So basically, if it's two numbers that isn't a whole number, then it can't be an int.
Right, exactly. Okay? So, you know, I'm not really going to get into like the trigonometric functions and stuff like that. Like if you know that stuff, great, you know, and then we can kind of work with it and stuff like that. And if we need to use it in class, I'll try to do a better job of explaining it. But for now, we just want to be comfortable with using math methods in general. Okay? All right. So the other thing that it's good to know in here is using basically like scientific notation. Okay? So let's just come up with another value here, z equal to, and let's say that we want z to equal something that you would see in like a science class, right? So we want it to equal 3.459 times 10 raised to the 12th power, okay? So it's a pretty big number. We don't want to have to write out all those zeros or stuff like that. So the way that we would do that in Java is we would go 3.459, and then you can do either a capital E or a lowercase e, and then put in a 12. Okay? So that e right there means times 10 to the 12th. All right? Yeah. So you maybe have seen this, like if you've used a like a scientific calculator, not a graphing calculator, but a scientific calculator. Usually it'll express numbers with an E right there. So it can be either a lowercase e or a capital E. And just so that there's no confusion here, if we did another variable y equal to this first number in front here, okay, this is technically called the Mantissa. The Mantissa can be negative, okay, so negative 2.156, right? And we could have spaces in here, so that could be an E, actually. All right, and we can put a negative exponent on there as well. So if I have a very big, very small number, we can do something like that as well. I think it'll let me put spaces in there, but maybe not. Okay. So I'm sorry, I said you could have spaces in there, but you can't. So the E in there could be capitalized or lowercase. You can have a negative mantissa, you can have a negative exponent. So if you know anything about scientific notation, negative exponent means it's a very small number, very close to 0, right? Positive exponent means it's further away from 0. Okay? So let's get back to, you guys feel okay now with using math methods and what we're doing here? There's a couple other things here that you know might be helpful at some point. Okay, there is, like, if I wanted to find the area of a circle or something, what do I need in order to find the area of a circle? I need to know the radius and I need to know pi. Okay, so if I wanted to know, let's say that I know like double radius equals, and then let's just say 13.6, okay, area of circle equals, okay, so we're going to do this with two different math things. So we know that the area of the circle is pi times r squared, okay, or we should. Okay, so pi is actually a constant in the math class. So I can use math.P as pi, and then I can do math.POW is for finding a power. Okay, so the base is going to be the radius, and the exponent is going to be 2 in this case. All right. And then that's how we could find the area of a circle using math constant pi and the math POW method, which is base and exponent. And then it gives me this area, 581 point blah blah blah.